Okay, so in today's video we're going to have a look at quadratic inequalities. Now for this topic you do need to have a pretty good understanding of factorising quadratics, so I'll link the videos for those in the description if you're not 100% sure. We're going to have a look at factorising quadratics where the coefficient of x squared is 1 or greater, and we're even going to have a look at some where you've got to use your calculator and we get the quadratic formula involved. But we'll kickstart with this question, so grab a piece of paper, grab a pen, make some notes, and we're going to fire straight into this. So for this first one it says solve x squared plus 5x plus 6 is less than 0. Now we'll deal with that less than 0 part at the moment, but for starters we just need to solve this like we would a normal quadratic, and that means factorising it. So we'll think about how we're going to factorise this. Now the factors of 6 are either 1 and 6 or 2 and 3, and if we want to make 5 in the middle, 2 and 3 there's going to work for us. So it's x plus 2, x plus 3. Now our solutions within those brackets is negative 2 for the first one, and we've got x equals negative 3 there for the second one. Now in order to do the next part of this we need to think about what this would look like if we were to draw the graph, and we only need to do a little sketch of it. But if we were to draw the parabola for this, we would have something that looked like this, and down here our solutions which we've got there are negative 2 and negative 3, hence why I've drawn it going through the negative part of the x-axis there. Now when it comes to these quadratic inequalities, we're either going to look at when it's less than 0, which is what we're doing in this question, or when it's greater than 0. Now I like to think of this less than or greater than 0 being above or below ground. So for less than 0 is below ground, and when I refer to the ground I mean the x-axis there. Now the bit of the curve that is below ground or less than 0 is this bit here, if I highlight that. And there's a way to show your answer for this bit. What this question is basically saying is which part of this quadratic, x squared plus 5x plus 6, is below ground, is less than 0. And you can see from the diagram there it's that part that I've highlighted, and that is between the values of negative 3 and negative 2. And the way to write that as an inequality is to do one of these inequalities here, where we say negative 3, negative 2 on the right, the smallest number on the left, the biggest number on the right, and that means it's between minus 3 and minus 2. Okay, and that's our final answer there, giving it as one part of the curve there that's between those 2 points. So we're going to have a look at another question where it's above ground or above 0 or bigger than 0. And we'll have a look at how to answer one of those as well. So here it is. Okay, so the same process again, we've got to factorise it. So again, factors are 20, we can have 1 and 20, 2 and 10, or 4 and 5. And this time we're trying to make negative 1 in the middle. So our factor pair that's going to make negative 1 is going to be x plus 4 and x minus 5, and that makes negative 1 in the middle. And again, our two solutions here, we've got x equals negative 4 and we've got x equals positive 5. And if we draw again a little sketch of this, it's going to look slightly different because we've got one negative solution and one positive solution, but it'd look something like this, okay, just as a rough sketch. So we've got negative 4 over here and positive 5 on the x-axis over there. Now in this question it says above 0 or above ground. Now the bit of the curve which is above ground is this bit here, and also this bit over here. Now this is where this question differs slightly, because we've got two bits of the curve there to actually write a solution for. We've got the bit on the right here where all the x coordinates for that part of the curve are going to be bigger than 5. So we can say that, we can say x has got to be bigger than 5. And there's one solution. And then we've got the left part of the curve over here where all the x coordinates are going to have to be less than 4. So we can say that as an inequality as well. We can say x has got to be also less than 4. And both of those there are our answers. We've got x has got to be less than 4 and x has got to be bigger than 5. So when we've got above ground and we've got a curve like this, we've got two solutions there, two answers that we need to give for our inequality. Right. There's the two options, so here's a few for you to have a go at. Okay, so there's two questions, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so for the first one. Now this first one factorises to become x plus 4 and x plus 2. And our two solutions within those brackets are minus 4 and minus 2. And if we draw a little sketch of this curve, both going through the negative part on the x-axis, we've got minus 2 and minus 4, so minus 4 and minus 2. Now we are looking at when it's bigger than 0, so that's these two parts of the curve above the x-axis, and our solutions for that would be x has got to be less than the smaller value, which is minus 4, and x has got to be bigger than the higher value there, which is -2. And there is our answers for this question. X has got to be less than -4 and X has got to be bigger than -2. Moving on to the next one. This factorises as X plus 6 and X minus 5. That gives us +1 in the middle. And our two solutions for that are X equals -6 and X equals +5. And again, if we draw a little sketch of this, let's see what it looks like. We've got 1 in the negative, 1 in the positive. So we've got -6 and we've got +5. Now this question says less than 0, so we are looking at this one part of the curve here below the axes, and because it's one part of the curve, or one bit of solution there, we just need to write one inequality, and that's with -6 on the left and 5 on the right, and that again, that inequality just means all the values between -6 and 5. Let's have a look at some slightly harder ones to factorise. Okay, so when we've got a quadratic here with a coefficient of x squared bigger than 1, we just need to take that into account when we're factorising. So we're going to have 2x in one of our brackets here if we've got a 2x squared, and x in the other. And again, our factors of 9 are either 1 and 9 or 3 and 3. And remembering this time one of them is going to double. Now if I want to make 11, I want to try and double the 1 because I can use 2 and 9 then to make 11. So if we double the 1 goes here and the 9 goes over there, and then we just need to look at the symbols. Now we've got a +9 at the end, so that tells us that they both have to be negative in order to make -11 in the middle. So if I put those both in, and then just double check, 2x times the -1 would make -2x, and -9 times the x make -9x, and when you combine them you get your -11x in the middle. But don't be afraid just to expand that and double check it if you're not sure. Again, obviously make sure you have a look at my factorising videos if you're not 100% on this topic. So my two solutions are, on the right we've got x equals 1, and on the left we've got x equals 9/2 or 4.5. Okay, you can write that as a decimal as well. And then again, just like before, we'll draw a little sketch of this curve, both positive. So maybe it looks something like this, obviously not to scale. So we've got 1 and we've got 4.5. And then what part of the curve we're looking at? We're looking at bigger than 0. So it's these two parts here. And our inequalities, therefore, will have two of them. So for this bit, we've got x has got to be bigger than 4.5. And for the left part here, we've got x has also got to be less than 1, and there's our two solutions there. X is bigger than 4.5 and x is less than 1. Let's have a look at one more before you have a go. Okay, same style of question, same process, but we've got a 3x squared, so that just means we have to have a 3x. So we've got 3x in one and x in the other. And again, factors of 10, we can have 1 and 10 or 2 and 5, and one of them's going to triple this time. So to make 17, we can triple the 5, that'd make 15, and then add the extra 2. So we put the 5 in the other bracket, and that gives us 15 and 2, and it's all positive symbols here in the quadratic, so everything's positive. So we have for the one on the right there, x equals -5, and the one on the left, x equals -2/3. And then again, we can draw a little curve for this. So they're both negative, so they're both going to be in this negative part of the x-axis. And let's have a look, we've got -2/3, and here we've got -5. And let's just move that up a little bit. Right, there we go. So, which part of the curve are we looking at? Well, it's less than 0, so that's the bit below ground. We've got this part of the curve here, which means we've just got a single inequality again between these two values. So the smallest value on the left, -5, and the larger value, -2/3, on the right there, and there is our inequality for the solution for solving this quadratic inequality. Okay, so just some slightly harder factorising there, but here's a few for you to have a go at. Okay, so here's two questions, so pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so for the first one, we've got 2x and x in our two brackets, and the factors of 1, we've only got 1 and 1 as an option, so they both have to be 1 in there. Now in order to make -1, we want the 1 over here to double to make that -2, and this one to be +1 to make that +1 and -2, which will give us that -1 in the middle. So our two solutions there, we've got x equals 1 and x equals -1/2. And if we draw our little curve for this, we've got 1 negative, 1 positive. So we've got -1/2 and 1. And for this part, we are looking at less than 0. So we're looking at the part here below the x-axis. So we've got a single inequality for our answer for this one. And that single inequality is going to be -1/2 and 1. And again, just remembering that inequality there just means all the numbers for x between -0.5 and 1. And moving on to the next one, our last one here, we've got the factors of 6, which will be 2 and 3, or 1 and 6. And we've got a 3x in the bracket there, so 3x and x. And what pair is going to make -11 in the middle? Now, one of them is going to triple, so we want to triple the 3, that'll make 9, and leave the 2 as it is, so we'll have 3 and 2. Now we're trying to make the -11, and we've got a positive 6 at the end, so these are both negative. And then we can get our two solutions, so x equals 2 over 3, or 1.5. 2 over 3, or 2/3, and x equals 3 for the one on the right. There we go. And these are both positive, so let's keep them both in the positive section of the x-axis. And we've got 2/3 and 3, so 2/3 and 3. And in this question it's saying bigger than 0, so we're looking at the two parts of the curve above the x-axis, and again that means we're going to have our two solutions. So for the one on the right here, we've got x has got to be bigger than 3, and for the one on the left here, we've got x has got to be less than 2/3. There we go, and there we are, there are our two solutions for this particular quadratic. Now let's have a look at something else. Okay, so just one question on this before you have a go, and that is work out the integer values that satisfy, and we've got x squared minus 7x plus 11 is less than 0. So it says integer values meaning whole numbers, okay, that's what an integer is. So let's have a look at how we're going to approach this, because it's a little bit different. So this says x squared minus 7x plus 11 is less than 0. And if we go about trying to factorise this, we can only have 1 and 11, and there's no way that I'm going to make 7 out of that. And that gives us a hint here, and the fact that it's mentioned whole numbers as well has given me a little hint that we're going to have to use the quadratic formula. So when I can't factorise, always just jump straight to the quadratic formula. So we've got minus b plus and minus the square root of b squared minus 4ac, and that's all over 2a. And again, if you're not 100% with the quadratic formula, I've got a video on that. It's all in my algebra playlist, so just go and check that out if you're not sure. So the values of a, b and c in this question, a is 1 in front of the x squared, b is -7, and c equals 11. There we go, and let's get rid of that now we know we can't factorise. So if I put that into the quadratic formula, let's see what we get. Well, it's -b, so that swaps -7 to become +7, plus and minus the square root of -7 squared is 49. Don't forget when you square a negative, it just becomes positive, so we've got 49 there. 49 minus 4 times a times c. 4 times a is 1, so 4 times 1 times 11 is, 4 times 11, so 44. So we've got take away 44. There we go, write that in there. You've just got to be careful when that 4ac becomes negative and not forgetting that that becomes a plus. But there we go, hopefully you're okay with that if you've obviously done some work on the quadratic formula. And then that's over 2a, 2 lots of 1 is 2. Right, so typing that into the calculator then, so I'm just going to press my fraction button, 7 plus the square root of, and let's see, 49 take away 44 is 5, so it's the square root of 5 in there, so I'm just going to put that in, 7 plus the square root of 5 over 2, so we get this, let's have a look, we get one value there, when I've done the plus, I get the value 4.618 and some further decimals, but I'm just going to leave it as it is. And then I get another one for my minus, so I'm going to go back into the calculator, put minus in, and for the answer for that, I get 2.382 if I round it. There we go. So they're my two solutions, okay, not exact there because I've rounded these, but that's not going to matter in terms of what we're going to do for this question. So if I again draw a curve and just think about what it would look like, we've got one value here, which is 2.38, let's just round it to 2.4 so I can write it down, and we've got another value here which is 4.6. Now it does say the part of the curve that's less than 0, so again we are looking at this bit here, and it says work out the integer values or the whole numbers that are between these 2 points. Look, so what whole numbers are between 2.4 and 4.6? Well, a little bit further along from 2.4 we'd have 3, and then we'd also have 4 above in front of 4.6 there. If we were to write this as an inequality, we'd have 2.382, and on the other side 4.618, and it's saying what whole numbers are between these two values? Well, definitely 3, and 4. Okay, not big enough to get to 5 because obviously it cuts off at 4.6, but 3 and 4 are between those two solutions there. So they are the integer values that satisfy that inequality. Anything less than 2.4 or higher than 4.6 would not be less than 0 there when you sub them in. So they are the two values that we've got. Now I've got one for you to have a go at here. Again, you'll be using the quadratic formula. So here it is. Okay, so here's your question to have a go at. So pause the video there and we'll go over the answer in a sec. Okay, so work out the integer values that satisfy this inequality. Now again, we can't factorise this. Look, if you think about the factors of 10, you've got 2 and 5 or 1 and 10, and neither of those you're going to make negative 10 out, even when you double one. You could have 4 and 5, which would make 9, or you're almost getting there, or you could have 2 and 10, or even, I'm trying to think about how if you could potentially factorise it, but you definitely can't. But it's always worth just having a think to think if you can actually factorise that. So straight into your quadratic formula, we've got a equals 2 in front of x squared. We've got b equaling negative 10, and we've got c equals positive 10. There we go. And if we've put this into the quadratic formula, let's have a look. We've got negative b, which is 10, plus and minus, obviously swapping the negative 10 to there because it's negative b, 10 squared, which is 100, take away 4 lots of ac, so 4 times 2 is 8, times c is 80. So we've got 100 minus 80 there. Obviously just take your time working that out. That's 4 times 2 times 10 that I've just done to get my 80 there. And that's all over 2a. 2 lots of 2 is 4, so it's all over 4. So for my positive answer and my negative answer, I'm going to have to do this on the calculator. So press my fraction button, 10 plus the square root of, and 100 minus 80 is 20, so I'll just put 20 in, and that's all over 4. Press equals, turn it into a decimal, and I get 3.618, and again I'm not going to write down all the decimals there. Back into your calculator, swap your plus for a minus, press equals again, and we've got 1.382 if I round that. There we go, and there's our two answers. So thinking about what this would look like, both positive there, so both in the positive part of the x-axis, and we have 1.38, and here 3.62 if I round it. Again, it doesn't really matter here if I'm rounding them, just because of what we're actually trying to figure out here. Now again, it's less than 0, so we are looking at these values underneath, and the whole numbers that satisfy that, look, in between 1.38 and 3.62. Again, if we write it as an inequality, we've got 1.38 and 3.62, and the whole numbers between that, we can have 2 and we can have 3. There we go, and there are our two solutions for this quadratic inequality there that satisfy that. We've got 2 and 3 that would fit within that inequality. Right, I've got one more question to have a look at before we finish. Okay, so this question says n is an integer, so a whole number, such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is greater than 1. Find all the possible values of n. So we've got two inequalities to have a look at here. So I am going to go over this, but pause the video, see if you can get somewhere with it, see if you can solve anything, see what you can make of it, and we'll go over the answers in a sec. Okay, so we've got some inequalities to solve. Now this first one is quite nice and easy for us to solve. So if we actually just take away 2 from both sides, we can just solve this. It's just a linear inequality that we can solve hopefully quite nice and easy. So we've got 3n is less than or equal to 12, and dividing by 3, we've got n is less than or equal to 4. So that's going to be part of our solution there, that n has got to be less than or equal to 4. Then we can move on to this second one. So we've got another inequality over here, and it does look a bit different. We've got 6n over n squared plus 5 is bigger than 1. Now the first thing to do is we need to get this into a single line equaling 0, or not equaling 0, but 0 on one side. So in order to do that, I'm going to multiply this denominator over. So I'm going to times both sides by n squared plus 5. And as it's only 1 on the right hand side, that's quite nice and easy, because it's just going to slot next to the 1 there. So first things first, if we do that, we get 6n is greater than n squared plus 5. Now I want to get 0 on one side. Now to avoid getting a negative n squared, I'm going to move this 6n to the other side. So I'm going to minus 6n so that we've got 0 there, just like any normal quadratic. So once we do that, and if I slot the 6n in after the n squared, you get n squared minus 6n plus 5, and that was 0 is greater than that. Okay, 0 being on the left-hand side. Now, unlike a quadratic equation, I can't just swap that 0 over to the other side, or I can, but I've got to do something a little bit different here when I swap my inequality to the other side if I need to do this. Now, in order to swap it to the other side, the inequality is going to flip over. And think about this logically. If I say 0 is bigger than this, let's just think about a little logical one. I'm going to rub this out, but here's just something to think about. If I say that 2 is less than 5, which it is. If I want to move to the 2 to the other side, I would have to say 5 is greater than 2. Okay, so if I just want to flip that 2 onto the other side, I have to also flip the inequality over, and that same logic applies to this question here. But hopefully that's going to help you to understand why the inequality flips over. So if I do that, we get n squared minus 6n plus 5 is less than 0. So I'll get rid of this because we're going to do some more working out for this question. Right, so now we've got an inequality there, a quadratic inequality that we can factorise and solve. So if I go about doing that, in my brackets, it's they've got to multiply to make 5, so it's 1 and 5, and it's minus 6 in the middle, so it's n minus 1 and n minus 5 that's less than 0. And obviously don't forget that it's less than 0 that we're looking at here, so we're going to be thinking about that on this next part. So if I draw a little sketch of the curve, it's going to be, let's write down the solutions as well. I'll write them up here. We've got n equals 1 and we've got n equals 5. And if I draw my little curve for that, there we go. We've got 1 and 5 and it's less than 0. So we are looking at this part below the curve there. So my inequality for this will be a single one and it's 1 and 5. There we go. Right, so that's my inequality done for the second one. Now what we've got is two inequalities. We've got our first one here that says n has got to be less than or equal to 4, and our second one here that says it's got to be between 1 and 5. So what numbers are between 1 and 5 that are also less than or equal to 4? Now when you've got to write the numbers that are within the inequality here, let's just think about this one to start with. Now the numbers that fall in between that, the whole numbers, the integers, are 2, 3 and 4, okay, but not including 1 and 5. Now the first inequality says that n can be less than or equal to 4, so that doesn't actually not disinclude any of the numbers here within our solution. So 2, 3 and 4 there are between 1 and 5, not including 1 and 5 because there's no equal to symbol on our inequalities there, and it's also less than or equal to 4. So our solution here is 2, 3 and 4 as our final answer. And there we go, that is the end of quadratic inequalities. There are obviously some different scenarios. We could mix up the equations slightly and have them not having them equal to 0, but this was just mainly just focusing on actually looking at solving these questions. So hopefully you found that useful. If it was helpful, please like, please comment, please subscribe, and I'll see you for the next video.